So right now I'm just assembling some of the isolation flanges that are going to be mounted on these circulators for one of the systems I'm working on. The one I'm doing is actually a 6-zone system, all circulators. The 6th one is actually going to be a spare future zone, so that one will not have a circulator, but it'll have the flanges at least built into the system, so we could add the circulator when we determine what size it needs to be. Trying to read comments as they come into and work on them, so you might see me going back and forth. I see you guys saying what's up and hello. How you guys doing? I'm sure if you're watching the live video, you're at least familiar with what I might be doing right now, but I'm just assembling some flanges on some circulators. We're in the middle of a build, actually a few builds. I'll actually turn the camera around in a second here once I finish this and show you the system that I just finished up. And we're already moving on to the next one, and we have a whole queue lined up here bringing us into the winter season, and usually that's when I get pretty slammed with all this because we get people that realize they need to replace their boiler as soon as it starts getting cold. So if it's something you're thinking about doing, you're better off doing it sooner than later, because I do get pretty backed up. Right now, I'm pretty much about 3 to 4 weeks for a system, but in the winter, it could go up to 6-8 weeks at some point. All right, so I just got that one assembled. I'll just turn the camera around and do a quick little chat about the system I just finished up. That one's this here. So this one is a heat-only boiler, as opposed to a combi. And a combi, if you're not familiar, combi boiler will also provide domestic hot water out of the same unit. It would actually have some additional connections right here with some valves, service valves, and you could actually feed in your cold and get hot water out of the same unit. Now those usually work by, you can only run heating or hot water one at a time. So for example, if you turn on a faucet or a shower, your heating portion would shut off temporarily until you're done using your domestic water, and then when it's completed, it'll go back to your heating. So this one is a heat-only system. All the standard components as far as air separation. This one has a magnetic filter on it as well to filter any of the particles that are floating around in the system. This is going to be your pressure regulation here. This is a backflow preventer that will prevent any of the closed loop water from ever being able to get back into the public water supply. This circulator here, so this one here, some people wonder why there is a circulator just for the boiler. So the boiler has its own circulator to simply move the water in and out of the boiler, which is what's called the primary loop. all your other zones that you're heating are actually on your secondary loop. So all you're doing here, it's kind of hard to see under here, but you can see this is just teed in over here. So the boiler is simply just pumping hot water in and out of it. And then your zones are essentially stealing hot water from that loop. So the cold water that comes back from your heating system mixes with that loop that the boiler is supplying. So that way, what's really happening is the boiler is just always providing a set amount of flow rate and BTUs, and it's introducing that into this larger manifold here. And then your other loops are just stealing from that water. So if your zones are drawing a lot of heat out of the system, the return water will be cooler going back into the boiler, and the boiler will sense that, and it'll say, for some reason I'm getting cooler return water, I need to adjust my flame up and basically turn the heat up, and it's just going in a constant balance like that. But what's nice about having primary secondary is that your boiler just focuses on one thing, and it could stay at a steady rate. So we'll set this pump or circulator to, typically for this size boiler, this would stay on this high setting here, which is a specific gallons per minute to be able to deliver the maximum amount of BTUs that your zones will ever ask for. And then each circulator, maybe you only have one circulator running, maybe you have two, but you could have different flow rates in your secondary as you do in your primary. If you didn't have a primary pump and you tried running everything through the boiler, the load would change drastically, whether you have one pump running, two pumps running, however many zones. So primary, secondary just provides isolation of flow rates between the boiler's flow and your heating flow. I know it sounds sort of complicated if you're not familiar with it, but that's how these systems work. So this one actually has, it's actually 3 zones, but this is a pretty rare system, at least as far as it looks, because typically a 3-zone system would have either 3 circulators, or it would have 1 circulator with 3 zone valves. But the customer already has 2 circulators that feed radiant heat through some mixing valves. So what we did is he needed a zone for baseboard heating, which is what this pump will do. That'll feed the baseboard loop and return back through this pipe. This one here will go to the existing circulators that he already has installed, and this will be the return for those 2 zones. So even though we have a single feed, that's actually feeding 2 other zones. So 3-zone system. That's the one I just sort of wrapped up here. I think, yeah, this one's pretty much completed. Some people ask, where's the expansion tank? So usually I ship loose the expansion tank because it essentially hangs off of here. And once it's screwed in and filled with water and this whole thing's mounted on the wall, you got, gravity pulling it down, and it's no concern. But if we're throwing it in the back of a pickup or in a trailer, you don't want that thing just bouncing around in there. So I just ship them loose, and then that's the expansion tank in there. That'll get mounted on later. So here is the system I'm working on currently, and this one is quite a beast, if you will. I mean, that's a 4x8 sheet of plywood. That one's going to end up being probably a full sheet. You can see this one here that I cut it down. We have the 4-foot width, and I probably cut a few, it's right over there, probably a few feet off the top. So this one's actually going to end up taking an entire sheet of plywood, and that's because we're going to have 6 zones. We're going to have 5 circulators with a spare zone on the very end. So essentially 6 circulators this system will have, and also one on this side, which this circ, as you can see, it's actually stainless steel, and that's because it's going to be used for domestic hot water recirculation. So that pump right there is going to be responsible for pumping and keeping a loop hot all the time as far as the domestic hot water. So you have to use stainless or lead-free components on all of the domestic side, because that is a open loop system that's obviously going to be used for domestic hot water. So, I mean, it is your drinking water, if you will. So everything has to be lead-free or stainless. This circulator, which is the Takeo 008, does come in multiple variations. Most circulators do. You could get them in cast iron or stainless. So you can see these ones here are cast iron, because those are for the heating system, so it really doesn't matter. The other reason you'd want to use stainless is even if you had an open heating system that can introduce oxygen into the system, that's also why they make these circs. And that's exactly why we're using it on here, is not only for that it's lead-free for safety, but also that you don't want this thing corroding, because it's an open loop system for the domestic, and you're just going to constantly have oxygen introduced into the entire system, so it would corrode things eventually. So, hey William, I saw you commented, how much do you charge for your setup? So it really all depends, obviously. You could certainly see not one of them is ever the same. I mean, I do have a minimum cost, for example, for the smallest single zone heat only system. That might start around 6,000. That would be boiler, circulator. Sometimes if it's for like a radiant floor application, we would have the manifold for your loops mounted below and everything tied in. But pretty much minimum pricing is around 6,000, and then it can go upwards of pretty much whatever you can imagine, because we could build any possible system or configuration, especially when you get into snow melt systems where you're dealing with massive boilers, big pumps. It can get pretty pricey, but these systems are insanely efficient. So, and if you build it right and you use the right components, that's the biggest thing, is that can you purchase something for cheaper and get the job done? Yeah, likely. But I deal with that all the time. I get people all the time that contact me that say, hey, I ended up, trying to take the cheaper route, went with this or went with the cheaper bid, and I'm having these issues, or the boiler only lasted 2 years. I mean, it's because you have to do this correctly. There's a lot of plumbers out there that could just slap one of these on the wall, connect to it, and call it a boiler system. But there's a lot of things you need to think about, I also, I will not build a system unless it's the way I would do it in my own house. So if you want to cheap out, and I don't mean cheap out because you're just trying to be cheap, but if you actually don't have the money, I can certainly recommend things that you may not 100% necessarily need, or I would recommend, fixed speed circulators over variable speed pumps. There's things I could do to at least recommend what I would do if you're in a tight scenario and you need a heating system. And I'm not just going to charge premium to everyone and expect them to pay for it. So, but if you do want a quote or anything, just email me. My email is speranzadevelopment@gmail.com. It's always in all of my descriptions of videos and on my channel as well. So, all right, I'm going to get back over to getting some of these circs together. And yeah, William, I see your questions. If you can, just email me. Again, speranzadevelopment@gmail, and we could chat, and I could get you a quote for sure. And like I was saying before, the sooner the better, because if you could decide if you want to do it now. I don't know if it's something, let's see what you said, thinking about putting in High Ranch. Yeah, I mean, if it's a new construction or something you're looking to replace, either way, if you get to me sooner, the better. Get you on the schedule. This system is a little more time consuming just because of the amount of components, but we'll get this wrapped up within the next week here. We got a few of them going at the same time. I also do designs. So I'm not just building systems out here. So even though this system may take me, some of these systems might take me a few weeks, and that's because I'm only picking away at some of them, because I do a lot of other things, mostly with boilers, but I do a lot of design work. So if there's a system you want to build yourself, which will also save you money, because what I'll do is gather your information, we discuss, we get whatever info we need to design a full system for you. We could do everything from heat loss calcs to baseboard and radiant layouts or whatnot, and we'll design you a system and provide a full detailed schematic with a detailed parts list that you could pretty much purchase most if not all of your components online, and then we'll walk you through any of the setup, installation, commissioning it, filling it, startup, and you will save a ton, obviously, because I need to charge some markup and labor for what I do, but the designs are not as costly, and if you're capable enough, or at least have someone else possibly follow the plan and install it for you, that's also an option. That way you know the design you're getting is at least correct, and you're not going to be hiring someone that may not necessarily know what they're doing, or they may know just enough to provide some heat, and then you realize later you overpaid, or they just didn't install it correctly, and then you run into all sorts of issues. So I think I got one other thing I had to do. I didn't go live when I did this, but these circulators come, if you look, where is it? So you'll see there's an arrow here pointing to the direction of flow. Now, typically, all of these circulators come in the vertical pointing up position. So you actually just have to unscrew these 4 little Allen screws, and you can rotate this housing in whatever direction you want, so that it really doesn't matter. It will physically run in any direction without rotating it. But if you want the image to look correctly and the circulator be in the right position and everything uniform, so when you wire everything, it's all in the right direction, you can rotate these. You just want to be careful not to pop the housing out, and not the end of the world if you do, but it's a little more difficult to pop it all back together. But as long as you take the screws out, you can just rotate these and then put the screws right back in. So even if you're mounting this sideways, like we do in a lot of our systems as well, you can mount this in every single direction. So just be aware of that. I see a lot of, that's one other thing that just grinds my gears, is when I see professional installations that probably charged a premium and their circulators are upside down, sideways, whatever it may be. And yeah, in that case, that won't affect the performance or function. But for the, 2 minutes to 5 minutes it takes to just do it right and make it look right and professional, I feel like that's the way it should be done. You paid for it. So you just got to go the extra mile, if that makes sense. And even, you can see I'm kind of fiddling with this a little bit, but it's because I want to make sure these gaskets in here and these are seated correctly, and I want to make sure that the position, because there's some wiggle room where this isolation valve can actually move slightly around. Again, if it's just snug and a tight fit, it won't affect it. It'll still seal correctly, but I want to ensure that that thing is completely centered on there, so that when we press all of the piping together and somebody has to replace a circulator in the future, Everything is nice and aligned, and you don't have to fight with it. All right, so that's it. You can see too on this system, we have Pro Press up here, and then the bottom, we have a 1/2 inch PEX fitting. Now this is because this is not a standard system, but in this customer has a slightly unfortunate situation where they installed some excessively long loops. So we have, typically this circulator can pretty much deliver, I'll just use very standard terms here, but a typical amount of BTUs that would be needed for a concrete and for radiant application. It could probably deliver up to a dozen loops. It just all depends on the calcs and the BTU requirements. But in this case, we're actually hooking a single loop to this circulator. We'll be able to probably, some of them are 300 feet, some of them are 500 feet, there's one that's 800 feet, which is where we're using the 0013 TACO to push through a single loop. So we're dealing with some very high head loss, head pressure. So that's why we're going with single circulators on each individual loop. But we'll get it done. It's going to work. It's going to deliver the heat. That's just not ideal. So that is that. We're down to one more. And basically what I was getting at with that is that we'll be able to deliver the same amount of BTUs, but now we need to use 6 circulators or 6 pumps that you could have gotten away with a single pump. So the more loops you have, the shorter the loop lengths, the less the circulator has to work to get the job done. Even though you might spend a little bit more money on and labor on installing multiple loops, the cost is very minimal as opposed to purchasing 6 circulators and also running 6 circulators all the time as opposed to 1. Now these do run very, very low amperage. I'll actually show you how many amps we're talking about, because that's another thing people ask me all the time is how much energy do these actually draw? And they're just getting better and better every year. These are actually ECM electric or magnetic motors. So ECM circs, which I think on here, let's just say, yeah, so this actually rating, or is it, let me get in the camera here, so 0.54 amps, so a half an amp. Half an amp is not much, but when you got 6 of them and you got them running more often than they would need to, it adds up. But some of your older standard circs might run 1.5 amps or so. So if you think about that, if you got a 5-zone or 6-zone system with 1.5 amps, I mean, now you could be running 10 amps when all of your zones are calling for heat. This cuts it in less than half using these more modern ECM pumps. So, where's another labels? Then you also could get into, I don't actually have one handy. I got some in the attic and stock up there, but for now I'll just describe it. But there's variable speed circulators, and those will save you even more energy. So for example, a variable speed circulator can vary its speed. It's in the name. You could get one that essentially would have the same maximum amount of power as this circulator would. However, it could modulate down and draw even less if needed. So how that works is it uses temperature sensors. So you could actually set the delta that you want going in and out of your heating zone or your loop or whatever it may be. So for example, if you have a baseboard zone, you could set the circulator to always maintain a 20-degree difference between the supply water that's feeding the baseboards and whatever's coming back. So there's two temperature sensors that would come right out of the circulator. You'd attach one to the supply side and you'd attach one to the return side that's going back to the boiler. And what it'll do is it'll look at those temperatures. So for example, if you're getting 180 degrees, it's going to always give back 160 degrees. Now what that means is if it's a warmer day and the heat's being transferred more easily, you might need to draw less energy to do that. It also works really good for multiple zone valve systems. So if one zone is open versus 6 zones, it could adjust its speed according to what's going on with the heating system. So long term saves you money even more, and it guarantees your boiler's always seeing that 20-degree difference, which also can lock it into condensing mode. There's a lot to it. So all right, so that's the final circulator, at least to get together for this system. I'm just going to place it over here. These will actually be for the future zone. Let's see, so those will just get piped in, and obviously there's no circulator mount because we have to still design that portion of the home's radiant layout. We did plan for already the amount of BTU loss, so we probably already could size the circulator, but we're just going to hold off because we may not even install that one for a few years or so, or at least the customer might not. So we at least want to design the system to be able to handle it in the future. And you don't want a circulator just sitting there for 1, 2, 3 years just not ever being used. So you're better off just saving it and purchasing it later. Let's walk back over. Bring these over here. Now you can see our layout is getting busier by the minute here. Can look a little overwhelming if you're not used to this, but you can sort of see the layout I'm trying to go with. But we're essentially going to have our supply come up over the top, feed down to each circulator, and then our returns are going to come and tie into those fittings, and then come back, pass over this manifold, and back into this side. Also running through this Naviclean, which will be mounted here. It's going to be busy. It'll be pretty tight so that we can fit everything on here, but it's going to look really pretty when it's done. This one's pretty exciting just because there's a lot going on. A little challenging to get everything uniform and fit in there, but we'll do it. So I'm going to probably call it a night in a little bit, get into the office and work on a few designs and some quotes and whatnot. Look forward to your email, William. We'll talk to you soon. And yeah, if anybody else out there is looking for a pre-built system or design, again, my contact info is speranzadevelopment@gmail.com. You could also find it in the description of all my videos and on my channel's info. So I think that's it. And I guess with that said, we'll see you guys soon.